Kia ora tato. I hope everyone is doing well during this level 2 lockdown or level 4 lockdown. I would like to thank the NZ-AIRS committee for the opportunity to present at this NZ-AIRS panel session. I also would like to congratulate the NZ-AIRS committee for the very successful organization of this conference. I will be presenting some of the initiatives for this presentation. I will be presenting some of the initiatives on ecosystem services globally and in New Zealand. And I will also describe a framework that helps assess some of the key ecosystem services provided by planted forests and discuss how the assessment results may be used to support the sustainable management of planted forests. Because my background, basically I'm focusing more on the forest resources, so that's my focus of the presentation here. Okay, so next slide. Can everybody see my pointer? Can you see the that I'm
Yes, we can.
Yes, we can.
Oh yeah, thank you. Anyway, just to clarify. Okay, so our world currently faces unprecedented and interconnected challenges, which include climate change, which we have heard, in the past presentation. Also, we have biodiversity loss and environmental degradation, and humans have now been adapting and working hard to address these challenges. And New Zealand regulations are being put in place, and we have started to change our agriculture and forestry systems by reducing stocking rate. And we've also done some riparian planting. And the good thing is that scientific information on the links of between humans and nature can help solve these problems. Okay. So there are several ecosystem service assessment frameworks that have been developed over the past decades. And this recent one was developed by Ian Bateman and Georgina Mays. The paper they published in Nature, sustainability is titled as the, as the natural capital framework for supporting a sustainably efficient and equitable decision making. In the diagram, the three circles on the top actually represent human and social capital and manufactured and other capitals. So these capitals are connected with the natural capital and natural processes to capital substitution and also to well-being related goods and services. And then in the next slide, we'll be focusing on this particular diagram. Okay, so to give you a walkthrough of this diagram, let us imagine ourselves to be in a farm forest. So by imagining that the natural capital of interest is a farm forestry, which is a sheep and beef farm with a section of forestry, the farm forestry has a finite set of natural capital, which includes air, water, soil, geology, and also natural processes such as nutrient cycling and water cycling. And it also has okay, so the farm forestry provides a flow of ecosystem services such as crop, livestock, trees, and pollination, and as well as landscapes. So it also has riparian planting and a QE2 covenant area that both improve water quality and quantity, as well as provide habitats for some native birds species. So these wonderful ecosystem services provide well-being related goods and services such as improved physical and mental health, food, drinking water, and recreation. And these goods and services can be measured using economic valuation techniques and other methods. The non-market value of recreation values can be measured using travel costs, while improved water quality can be measured using choice experiments. And the total economic value of which is actually embedded in this ecosystem service framework. And we can also embed other approaches to measure other values like cultural and social values. And then this gives you this set of measured values which we can use to do cost benefit analysis and appraisals that may be used to sustainably efficient and equitable decision making. Okay. So with the help of Scopus, I was able to do a counting of the published documents on ecosystem services. It started with a publication in 1984, and then the Global Ecosystem Service Assessment was undertaken by more than 1,000 scientists and practitioners, which happened in the early 2000s. And this contributed to the significant increase in the number of publications on ecosystem services in the following years. The ecosystem service framework has been applied numerous times and has been further developed over the past 2 decades. There is actually now a journal on ecosystem services, which has an impact factor of 5.45. And 2 days ago, we have almost 38,000 publications on ecosystem services, showing that there's been the science has improved significantly, and these publications are actually more than 10 times as those of the bioeconomy and natural capital. Okay, so in terms of international initiatives, so I mentioned that in 2005, the Global Millennium Ecosystem Assessment was published. This gained a lot of attention, which resulted to several countries undertaking their own respective national ecosystem service assessments. And in 2014, the United Nations, along with other international institutions, discussed in detail how to standardize the different measures of ecosystem services, and they compiled those discussions into this 2014 document called Experimental Ecosystem Accounting. And a number of ecosystem service guides for policymakers have been created, including this one published in 2020. And earlier this year, the United Nations has adopted a new statistical standard to measure the value of ecosystem services. So the experimental ecosystem accounting has been elevated to ecosystem accounting in this document. Ecosystem accountants have been working with economists and ecologists to identify strategies to somewhat standardize valuation techniques so that their estimates would be more readily incorporated into the developing system of ecosystem accounts. So the accounts are a new set of measure to represent natural capital and ecosystem services into the system of national accounts, which are used in decision-making processes. Okay, so I think in the previous presentations, some mentioned the Sustainable Development Goals, or SDGs. So like Nicholas Shotbolt mentioned SDG yesterday in her keynote presentation. So ecosystem services are linked with 10 out of 17 SDGs. So ES are indirectly linked with SDG 1, 2, and 8, and directly linked with at least 7 SDGs, as you can see in this figure. And there's a paper by Wood et al. 2018, which suggests that out of the 169 SDG targets, 44 SDG targets focus directly on improving the environment and human well-being. And a survey of experts suggests that ecosystem services make important contributions to 41 SDG targets. So it's very helpful when it comes to SDG reporting. And in New Zealand, government agencies and in the industry have embraced the concept of looking at the wider value of ecosystems. For example, the Waikato Regional Council published this document called Applying an Ecosystem Service Approach to Policy Development. The document mentioned the term ecosystem services 346 times. And on the middle panel, you have the Department of Conservation, MFE, and Stats New Zealand having this document showing that they also embrace the concepts as, if you could actually find those, the definition of ecosystem service in these documents. And even the New Zealand Treasury has created the Living Standards Framework, which includes the natural capital and ecosystem services as one of the 4 capitals. So the forest company owned by Dunedin City Council, City Forests, in the website, they highlight the multiple ecosystem services provided by their forests on their web. Yeah. Okay, so just a definition of ecosystem services. So it's actually evolved from the benefits that we get from ecosystems to a more inclusive definition. It's now called as the goods and services provided by natural and modified ecosystems that benefit, sustain, and support human well-being. So there are 3 main groups of services. First is the provisioning, which are the material benefits that we get from an ecosystem. So it includes timber, fiber, food, understory crops, firewood, and water. And then the regulating group of services. So these are the environmental benefits that humans indirectly benefit from. So it includes carbon sequestration, avoided erosion, avoided nitrogen leaching, and habitats. And the third group is the cultural, which are the non-material benefits, such as recreation, aesthetics, education, and cultural heritage. So having this lens, if we look at a planted forest, so we can see that it's not just timber, but you also have this, you can have high value understory crops like ginseng, here. And then you have these fire ponds in the South Island. They actually provide habitats for our endangered freshwater crayfish. And planted forests also provide habitats for our iconic native birds. And a number of our planted forests, they give access to mountain biking and other recreation, also recreational hunting, and you have some native remnant vegetation, as well as they also provide some water filtration. And the full value of planted forest ecosystem service is difficult to measure, especially when considering the non-market benefits. However, this work is vital as it further contributes to the value of forest management systems that support balanced economic, social, cultural, and environmental outcomes. Okay, so and that's one reason why several ecosystem service quantification and modeling tools have been developed globally. One group of tools on the spatial economic quantification of ecosystem service. One with the tools focus on the spatial economic quantification of ecosystem services. And at Scion, we have developed this framework called Forest Investment Framework, or FIF. It's a tool that combines data from spatial productivity, economic, and environmental models. And out of this data, we can actually assess whether, if you have a piece of land, we would be able to tell you if it's going to be profitable or not, whether you plant exotic species or native tree species. And then we can also quantify, given that we have the productivity layer here, we can quantify the carbon sequestration. And also, we have an environmental model that actually provides an estimation of avoided erosion values. And we were actually approached by Winita Forest Products to quantify the ecosystem services in their forests and to somewhat support their decision-making and certification. So we use FIF to look at the timber profit across the 30,000 hectare forests. And then we also quantified carbon sequestration and avoided erosion. And then given that we have quantified them, we can also stack them up. And we can see here that the value of combined value of carbon and avoided erosion can actually be more than the value of timber, which is the main reason why they planted this forest. And on top of that, they also, half of the forest is open for recreational hunting. And you can see this happy man getting this nice pig. And then we were able to quantify that the value of pig hunting was about $250,000 per year. And this information was able to help Winita, do more planning on the sustainability of the forest, as well as successfully renew their forest certification. Okay, so application of FIF in New Zealand. So basically, between 2014 and up to present, FIF was used to help inform stakeholder decisions, like Maori landowners approach Scion to assess the afforestation potential of their land. MPI and regional councils have asked us to support their regional economic development studies, and government agencies and forest owners requested us to do this ecosystem service assessment. So we have done 10 case studies. And then FIF to date was applied in more than 22 case studies at the national, regional, and forest estate levels. And we have been getting some new requests from clients, as well as some clients who already asked us to do FIF analysis earlier. So FIF has about 7 ecosystem service value functions. So timber, and then carbon, and all the way to biodiversity enhancement and recreation. So we use the FIF 4 functions: timber, carbon, avoided erosion, and avoided nitrogen leaching, to look at the broader value of the 1.7 million hectares New Zealand planted forest state. So we recently published this in the special issue of Forests journal. Our co-authors include Sally Strang and Colin Monder. They're actually the environmental managers of the 2 biggest planted forest companies in New Zealand. Okay, so first we identified where is this 1.75 million hectares of forests, planted forests, and then we use FIF to quantify timber, carbon sequestration, avoided nutrients, and avoided erosion. And you can see here in the avoided erosion panel that you have dark areas here, meaning that these areas in Gisborne, they provide very high avoided erosion values. And given that we have the values, we can stack them up, and we can see here that in terms of timber value, or the blue one, Northland actually it accounts for only like 12% of the value, and then the rest are ecosystem. And then we can look at Gisborne, where you can see that a large proportion of the value there avoided erosion value. So indicating that the environmental values from planted forests can be more than the value of timber that we're getting. And for your information, this was done a few years ago, so the carbon price was just $18. So now if it's 50, so it might be even the carbon value proportion would be even higher. Okay, so in addition to that, we have also interviewed managers of the 11 major forest owners. In the country, they represent about 60% of the planted forest estate. And then we asked them, what's the relevance of this quantified ecosystem services, for you as a forest company? And then they said, yeah, they're very relevant, and they can actually help with, license to operate, certification, sustainable forest management. It can also, help with the description that their forest is like a public attraction, and then helps with Doberman compliance. It's a good information for forest owners, as well as rural investment analysis. And also the forest manager here in Rotorua actually said that it's kind of helpful to recruit new staff, because we have this mountain biking facility here in Rotorua, and also for corporate ethic. Okay, in terms of ecosystem service values that have been used or could potentially be used to inform forest management decisions, these are the top two: biodiversity conservation in natural areas. Then you have water quality, and you also have maricultural values, and so many other wonderful services that they would like to be quantify, so that they could have a more informed and sustainable management. Okay, so at Scion we have some projects on ecosystem services. The forest investment framework we
have a minute left, Richard.
Yes, thank you for letting me know, Frank. So forest investment framework, it's been developed in 2012, and then it's been used by government agencies. So we still get requests. So we're still working on forest investment framework. And then we have done this forest ecosystem services forum starting in 2012. Some of you have attended this. We've been doing this annually. So it's basically talking about ecosystem services at the international, national, and on the ground level in New Zealand. And then we currently have this project on impacts of marine biosecurity measures on ecosystem services. We're doing with Cawthron, which is a 5-year MB program, which is quite exciting. We're working with different councils also. And the Waikato Regional Council, we have this partnership on this freshwater ecosystem services long-term project. So we have done already 3 phases, and we're currently working on our phase 4. And then we have this Catalyst project, wherein we do this ecosystem service optimization. And we have this value-based biosecurity risk assessment, wherein I'm leading the environmental values literature review. And we've been recently given a project by the Forest Growers Research to look at the value of recreation in planted forests. Conclusion, so I've shown that there's been, in the literature, lots of publications. There has been significant advances in the ecosystem service science, and we found a growing interest in ecosystem service assessment. And there's ongoing discussions on how to standardize the measurement of ecosystem services and other values, given that we now have this ecosystem accounting. And having information on the full value of ecosystems contribute to innovative practices that are sustainable. And there are opportunities also for decision makers to prioritize which particular investments would meet the quadruple bottom line. But we cannot easily translate spiritual values to dollar values. And that's the reason why in the Biological Heritage Challenge, we have this strategic outcome 3, which is a value-based biosecurity risk assessment framework for Aotearoa. And I'm leading the environmental values, and then I'm working with social scientists and Maori scientists, and also an economist. So Peter Tate is part of this one. So we're wanting to know, what values should we consider to inform this, biosecurity risk assessment. So that ends my presentation. So thank you very much.